This call is now being recorded.
Hello all. Am I audible?
Yes, ma'am.
Yeah,
Yes,
okay,
ma'am.
okay. Yeah. Shall we start the experiment? Okay, so okay, I am Padmini Bhatt. I will be taking up. Yeah, I will be taking up experiment. Experiment number 4. That is design and simulation of a regulated power supply. Okay. Now this experiment is the last experiment which you are doing in the multisim. So first, okay, you should know what is power supply. When we do any experiment, actually we need to know, okay, what is that, okay, why it is used, okay, how it can be used. So application comes at the end. So initially we should see, okay, how it can be designed, like what is the purpose and how it can be designed. So whatever we have shown is the like a diagram for the commercially available regulator. Now the name itself tells it is to regulate something. Okay, so what it is regulating? Now we have studied, okay, about voltage, current, all those things, power. Now so many cases, okay, so many applications need a constant voltage, okay, or constant power. Sometimes it is required at any cost. That voltage shouldn't be altered. Okay, but that is from the electronic part. From the electrical part, when we see, these voltages keeps on varying. Okay, it can be due to many reasons. It keeps varying. So how can I expect a constant 24-hour supply, any parameter, from a continuously varying parameter? So for that, this, okay, that is voltage regulator has come into picture. See, it is a system. It is designed to automatically maintain a constant voltage level. What is the constant level? That depends on your application. Okay, some may require constant 75 volt throughout. Okay, some may require constant minus 48 volt throughout. Okay, some may require, most of the cases you might be knowing, were requiring just 5 volt. Okay, your mobile or your computer, whatever you see, most of the cases we need constant 5 volt. So in such cases, these regulators we make use. Now you can ask, then should I use each time one source, one regulator to get one constant output? No, not necessarily. You can have one source, okay, then one regulator for one application, second regulator for second application, and so on. Because in a PCB or in a system, you may whatever you think, suppose for it is your CPU. Okay, in CPU, some of the cases, some of the parts require plus 12 volts, some of the part require plus 3.3 volts, and some require plus 5 volt. Okay, so for that you don't have to plug 3 AC things, AC connections. One AC connection is sufficient. From there you take the signal, pass it through the transformer, and then you regulate it separately. That is possible. Okay, so this is a tiny instrument, okay, which can be accommodated in any place for the regulation of the voltage. Most of the integrated circuits require a constant voltage with which it could operate. Okay, be it a simple logic gate or a complex microprocessor, they have their own operating voltage. The most common operating voltages are 3.3, 5 and 12. While we have batteries, okay, and DC adapters, okay, these you know. So somebody already might have got questioned, okay, might have the question in your mind. Why not batteries? Okay, batteries doesn't come in the required values. Okay, so 9 volt battery and I want 5 volt. So in such cases, these regulators come into picture. Okay. They cannot be directly connected to our circuit design since the voltage from them is not regulated. Okay, say for example, we have 9 volt battery, but we need to trigger a 5 volt relay. So what do I do to get that 5 volt? So this can be the design concept. Now see what design concept I am explaining. It is just for your reference, because when you do the experiment, you need to know what that particular component does. So for that purpose, I have given you the design here. Okay, just if you listen today, that is sufficient. Maybe it is not maybe exactly it is helpful for your Viva. Okay, but for your experiment, this is not there. Okay, so you can take a NPN transistor, okay, as a voltage follower. Now it should have a voltage divider. Some people by now may be thinking, can't I use a resistor? She says that, okay, I have a 9 volt battery. See here, I said that I have a 9 volt battery. I want a 5 volt output. So you may be thinking, can't I use a resistor? Because you have studied that resistor drops some voltage. So out of 9 volt, if 4 volt is dropped, you can make use of the remaining 5 volt. But remember that that resistor, okay, is directly, its drop is directly proportional to the input voltage what I give. Okay, now my problem is, okay, I am worried that the input current is varying. The input current whatever I am giving to the resistor is varying. So only I am worried about the constant output. If the input current varies, okay, subsequently the resistor drop varies. So if the resistor drop varies, then the output what I get is varying. So I cannot use a simple resistor. So it is not like however we think, okay, simple to have a particular constant voltage. So you go for a voltage divider, okay, connect that to a NPN transistor. NPN transistor, when we say, okay, you take it in a voltage follower configuration. When we say we have 3 leads to it, okay, voltage divider you connected to the base, 12 volt rail input you connected to the collector, and the output output of that component, wherever, like output we usually give it to load. Okay, output we usually give it to load. Now what is the load? For this regulator, what is the load? Whichever device requires a constant output is the load. Okay, so that load you give it to the emitter. Okay, now that voltage divider resistor, in the voltage divider resistor will be there, right? That resistor you should replace it with the Zener diode, because Zener diode is the one which has that characteristic. Okay, you have studied that Zener diode characteristic. If I give the voltage at one particular point, it suddenly breaks down. After that, how much ever you increase the current or decrease the current, the output remains constant. So that one feature of the Zener diode we are making use here. Okay, a stable voltage regulator has amplifiers with feedback and compensation, and feedback and compensation, and a few power stages. Power stages you can have depending on what is your output required. How much is it? Is it 12 volt or is it 24 volt, 30 volt? Okay, how is it? Depending on that, my power stage can vary. Okay, power stage, how am I varying? It is just a Darlington connection. Okay, like you studied in your basic electronics, right? Like one stage after the other. So in that way, it can be given. Now, if you see this diagram, see here. Okay, see here. This is the error amplifier. Now what it does, every this R1, every interval, it takes the sample, okay, it gives it here. This is a comparator now. Okay, you have studied about comparator, right? So this is a comparator. This is the reference voltage. At present my reference voltage is 5 volt. So if the difference, it discards. Okay, whatever this to this, the difference it discards, and 5 volt is sent here. So in this way, again one more sample of the input. So every time interval, regular time interval, samples are taken. It is compared. Okay, the difference is given out. Okay, then the constant value is given out to the transistor. So in this way, it works. Next. They also have a built-in error amplifier which samples the output. This is what I said. Okay, compares it with the reference voltage, calculates the difference, and drives the output transistor accordingly. Now, I did not tell you, okay, what happens to the difference voltage. Okay, if any difference is there, yes, obviously difference will be there. Okay, in the error amplifier. What happens to that difference voltage? We did not discuss. We are just bothered about the difference is discarded and the constant. Okay, with that reference, whatever the constant is there, that is given out to the transistor. Now that difference voltage will generate heat over there, because that is also in one or other form the energy has to come, right? So it will come out as a heat. So this is one not the major disadvantage, but this is one disadvantage of the regulator. Okay, it heats up if the if the difference is too high, that is a actual input to the present input, if it is too high, then actually it heats up. So even the regulator has the range. Okay, within this differences, within these differences of the input only it will work. After that, the performance is not accurate. Okay. It is desirable to have a transistor with high gain. Okay, when we say high gain, this thing is the major point is it takes less current. Okay, we don't want the current to be drawn to the regulator, because if the current is drawn to the regulator, then that current I must add it in the design of the entire circuit. My circuit is not the regulator. In the actual scenario, if we see, now we are designing regulator, but in the actual scenario, if we see, regulator is not my application. Regulator is one component in application. By adding regulator, I should not have a power drop. Okay, I should not have a power drop, so that I should add that power in the input only. So I should go for a transistor with high gain. The current that the regulator consumes to drive all this internal circuitry, okay, when the output is not loaded, is called the quiescent current, and this quiescent current is either in microamps or in nanoamps. Now the design has come that quiescent current, whatever I said, the minimum to minimum current required, okay, that is in nanoamps. Okay, here actually we use in the simplest form, we use 3 transistors on the power output stage, 2 of them in a Darlington configuration, that is one after the 2 stage. Okay, and the other is a current limiting device. Okay. Now we also have, if I have mailed the manual, you might have gone through it, and you know that it is capacitors are there. Okay, that is not mandatory, it is optional, since the feedback amplifiers reject the input ripple. Okay, so it should, and these capacitors see to it that does not pass through the output. Okay, that rejected ripples will not pass through the output. Yeah, this is the circuit given in the manual. See, this is the input voltage. This is the AC input voltage what we give. Okay, and this is the DC, like what I can say is, it is a regulating. No, well, I'll tell you. Wait. It is a rectified DC. This is. Okay, rectified DC. Now here ripples are there. Okay, this is DC because it is in one direction, the other direction it is not there, but it is ripple is there here. Okay, so these ripples we need to minimize it. Minimize. So to minimize, what do we do? This is the circuit. Okay, transformer, then rectifier, then filter, then regulator. This is the part which we have to study. Okay, but here the rectifier is there so that at least from AC it will convert to DC. Okay, then this is the filter to minimize this. Now rectifier output is like this. Okay, filter output can be like this. Okay, however, this again depends on how do you take the value of your C capacitance. Okay, this you have studied in your basic electronics. You should take the value of C such that it becomes almost a straight line. This is the load. Okay. Yeah, this is the circuit. Okay, see here AC, and this is the transformer. This is again suddenly, see from 230 volt, if I want 5 volt output, directly I cannot connect that to a regulator. Okay, so I need to step it down depending on the turns taken here. Okay, we can step it down. Maybe 230 volt 1:1 means it will be 230 only. Okay, or it can be 110 or less than that. Then it is passed through this rectifier. Okay, this this is the capacitor. Okay, here actually that ripples are minimized, and then it is given to the this is the decoupling which we have studied because the noise, okay, or the ripples should not pass it to the output, so it will be taken here. It will be taken in this direction. Okay, so this is the regulator. Okay, usually regulators, if you see, it will come in the what you call series of LM7805, okay, 78 dash dash, like this. Okay, now initially when they had designed the regulator with this concept, the utmost efficiency what they got was 78%, so the name is 78. Okay, now actually you get very high efficient regulators, but the name still is carried on, and this is your load. Okay, fine. Now these are the applications. Okay, now before talking coming to the conclusion, or shall we, okay, I'll finish it off. First let us complete the experiment, then I'll go for the this thing, what is that, discussion. Okay, application, your mobile phone charger. Okay, charger, see in where do we plug? 100 volt to 200 volt. Okay, and it has to give you 5 volt DC. Okay, then another example is your computer power supply. Again it takes, okay, 110 to 240 volt, and it provides however you want, 12, 5, 3.3, minus 12. Okay, and for the system to run, and for the laptop the output voltage of the power adapter is 19 to 20 volt. Okay, it is possible with the help of voltage regulator. And AC voltage regulator, yes, we have AC voltage regulator. Okay, it is called as a stabilizer. At home you might have seen the stabilizer. Okay, and it takes slightly fluctuating voltage and provides a stable AC voltage. Okay, this is usually used for fridge, TV, and so many things. Right, sometimes for treadmill, for so many things, wherever you feel that okay fluctuation is there, we go for stabilizer. That stabilizer is nothing but regulators. Okay, so this was about the experiment. Now coming to the working using the multisim. Stop sharing, wait. Yeah. Okay, so I heard that most of you have, most of you Okay, okay. Tell me whether is it, are you able to see the multisim screen? Somebody whom can I ask? Akanksha? Akanksha, unmute yourself and answer. Whether are you able to see?
No, ma'am.
No, no. It is not visible, right? Yeah. One second. Wait for a minute. Stop sharing. No. I'll answer one. Wait. I'll present now. Window. Share. Now is it? Now, yes, right? Yeah. You're getting it. Yeah. Okay. Yeah. Now in this, first we have to place the components, right? Let us go for a voltage source. So select all groups. Okay, in that sources are there. Go for a voltage source. AC voltage source. Okay, let us give the specification as it is given over there. 230 volt, 50 hertz. Yeah. Now next we'll go for a transformer. For that again place, select all groups. And that transformer is there. In that, take the value TS XFM R1. Okay, take that transformer. If you want, you can note down. Okay, later if you are trying, it is TS XF MR1. Okay, place it. And the ratings are ratio 1:1 or okay 0.07, because from 230 it has to come down to a 5 volt. Okay, so place that. Then we'll go for diodes. Okay, IN4007. Yeah, 4 diodes we'll take. Then you click on that. Okay, you turn it, rotate it 90 degree. Then you go for 2 capacitors. The values are one is 47 and one is 0.1. It is not 0.1, it is 0.33. Okay. Next we'll go for a resistor. Yeah, now we'll go for a regulator. LM78. 05, yeah, yeah, CT. Okay. Now rest is connection. As per the circuit diagram, we will do the connection. Ground. Yeah, we have to have a common ground now. Let us give the power supply to the connection of the power supply to the circuit. Okay, the connections are done now. Now next we need to measure the voltage. This experiment is very simple actually. Okay, we need to measure. So go for instruments. Okay, in that measurement probe. Now think where and all I should check. Okay, first I should check here. Okay, after the what is this rectifier, after the rectifier, okay, I should check. Then I should check just before the regulator. Then I should check after the regulator, right side of the regulator. Okay, so now here this you all might be knowing the in this measuring probe the ground is connected internally. Okay, now see 3 connections we have given. We are interested only in this the output one, but we need to see the intermediate values. So let us consider the other 2 also. Okay, now let us run the simulation. Let it run. Okay, here I think we will get an error. The mistake whatever we have done is the diode connection are for the minus 5 volt and the regulator whatever I have taken is for the plus 5 volt. So I think we'll cancel this. We'll abort this program. Okay. Let us change the let us change this regulator. I hope you understood the mistake. The connection of the diodes, okay, that is rectifier, okay, was for the minus 5 volt. but the regulator was we have kept is for the plus 5 volt. So we should have we definitely we would have got the error. So let us change the regulator for minus 5 volt. Yeah, I could have changed this diode, but I changed that. Later we'll see this one also, no problem. Okay, now here one measuring probe should be there. Simulate instruments. Yeah, fine. Now we'll run the program. Okay, we'll run the program. Yeah. Yes. See now, 1 second. Students, you make note. Here also the voltage is input is also the voltage after the thing is minus 4.35 and output is also minus 4.06. Okay, can anyone guess why this changes? In that time I'll come to know how much you have gone through it. I had designed it for 5 minus 5. Am I right? I have designed it for minus 5, but here we are getting minus 4. Who will answer me? Who can wait, let me check. Arul, can you unmute? Others also? Is not there. Arul is not there. Okay. Who is this? Bhavit Adyantaya. Can you unmute? Bhavit. Where are they? Am I audible? Yes, no.
Yes, ma'am.
Yeah. Bhavit, he can text me, but to unmute, why do you take so much of time? Bhavit, why do you think we are getting minus 4.6? You are seeing this, right? You are observing this, right? What happened, Bhavit? Okay. Misika, come online. Misika. Mic problem. She has mic problem. Who else is there? Kirti Rohit Gatti. Kirti Rohit.
Ma'am.
Yeah,
Yes,
yeah.
ma'am.
Yeah, Kirti, now actually you were observing this, right, when we were doing?
Yes, ma'am. Yes,
Yeah.
ma'am.
Now, can you tell why I am getting minus 4?
Mm,
I am,
because of the direction of the probe, maybe.
no, I didn't change the direction of the probe. Probe direction is correct. Minus is the expected one because instead of LM 8.8, 7.8, I
Yeah,
am using LM 7.9.
yeah, ma'am.
Okay. Huh. So, but still I'm getting minus 4.6. Have you gone through the manual?
No, ma'am.
Why? Huh? You were supposed to go through, right?
Yes, ma'am.
Then, yeah, those who know can actually text. Why am I getting? I'll give 1 minute time. I will give 1 minute time. Okay, those who can guess the answer can text me. Then only I'll do the changes if anything is there. Start texting immediately. Why am I getting minus 4 instead of minus 5? Any answer is okay. Whether it is right or wrong, I will decide. Not even a single answer? Okay. Yeah, I got one answer. Due to efficiency difference between LM80 and 79. Who is this? Ashwit. Okay, let me. This is not due to efficiency, Ashwit. Let me tell you. Okay, I'll give you a clue. It is due to manual error. Okay, it is due to human error. Okay, Megha Salian has typed it as capacitor is 2.2, 20 and 1. Exactly, Megha. Okay, I have used the same circuit. I changed it for negative minus 5 volt, but I did not change the capacitor and resistor values. So only I am getting that difference. Okay, so we'll change the capacitor value and check the final output. Only two of you could answer. Okay, others, what are they doing? Hmm? How many of you have gone through the manual? Just a text, yes or no. How many of you have? Day before yesterday night I have posted it. Okay. If you go through the manual, it will be easier for you. If you directly come and sit in the actual lab also, you were doing the same thing. Directly come to the lab. Okay, here from starting from A, we have to explain everything. What are you going to do? Okay, then it won't be efficient. But now actually you are at home. Okay, whenever we post, if you go through that, then this explanation becomes more interesting. Yeah. Actually, see, that issue, let it resolve, but check the output now on the screen. Okay, it has come already minus 5.05. The output is minus 5.05. The input is stepped down to minus 13.2. Why that value? Because the transistor ratio, we have taken it as 0.07. N2 by N1, we have taken it as 0.07. Okay, so we have got the negative regulator. Similarly, we can do for plus 5. Okay, plus 5 volt. That I think, well, wait. Okay, we'll go for plus 5 now. Yeah, see here. This is the circuit diagram for the plus 5. Here, check the diode connections, okay, directions, then values of the resistor, okay, then the regulator specification. Right now, yeah. Now we'll measure. Similarly, in 2 places, like last time, we'll measure in 2 places. One is, output of the rectifier and the output of the regulator. Yeah, let us run the program. You check here, same 13 point some, it is from 230 volt, and their output is exactly 5 volt. Okay, so done. Experiment is done. This is a simplest experiment I can say. Okay, but the theory we need to study. Okay, no? Yeah, now you can either you can text or you can ask me any doubt if you have. Okay, do you have any doubt? Okay, then I think I will call you for the discussion. Satvik Shetty. Satvik Shetty. Come online. Where is Satvik Shetty? No. Where you people are? Yeah. Sharvari Navada. Come online.
Yes, ma'am. Ma'am, I have network issues here.
Yeah, I can hear you. Okay. Now, do you have
But I
any?
couldn't attend the class much.
Is it?
Yes, ma'am. I left the meeting and I joined again now.
Okay. So you are unable to answer.
Yes, ma'am.
Okay.
I couldn't even hear the question.
The question is yet to ask. Okay.
No, I
Question I
couldn't hear
didn't.
what you were teaching. I could only see the screen.
Okay. Then how about Sai Prasad? Sai Prasad. Come on, Sai Prasad.
Yes, ma'am.
Yeah. Okay. You have attended the class, right?
Yes, ma'am.
Now, my question is, is it possible to have a adjustable regulator? Is it possible? Because now see, I want plus 5 volt. Okay. Again, maybe after some days for the same application, I may be requiring plus 13 volt. So, is it possible to have adjustable regulator? Do you have any? I know that you don't know. You have not studied that. But do you have any idea? Yes, we can use, or no, we cannot use. What is it?
We can use, ma'am.
We can have adjustable regulator.
Yes, ma'am.
Yeah. How do you think? How do you think? Any idea?
By
Any
changing capacitor.
it is not by changing the capacitor. Okay, it is in the what is that regulator. Now we have 7805 and all, right? So in
Yes,
the
ma'am.
regulator, I have explained that voltage divider circuit will be there. That resistor, if we use it as a variable resistor, then I can have variable regulator. Now actually it is available in the market also. It is a series of LM317.
Okay.
Okay, yeah. Now who will answer again? Namrata. Namrata, come online.
Yes, ma'am.
Yeah, you are listening to the class, right? Yeah. Okay. Do you find any disadvantage of the regulator? Any disadvantage of the regulator? No? Okay. Otherwise, you at least tell me advantages of the regulator. Applications like, ma'am, I have seen the regulator here, ma'am, I have seen regulator there. Okay. Yeah, any of this thing. Actually, people can text me disadvantage of the regulator. Many are there, but none of them are coming online. Lokanath Prabhu, that girl
Yes, ma'am.
muted. Lokanath Prabhu is there, right? Yeah.
Yes.
Yeah. Can you tell the disadvantage of the regulator?
No, I don't know.
You found that is a ultimate device.
No, ma'am,
This,
but I.
you don't know that? Okay. Have you used regulator anywhere at home?
Yes, ma'am.
Where are you using?
Uh, in charger.
Charger regulator is there, or have you put for your TV stabilizer?
Yes, yes, ma'am.
Fridge
Fridge for fridge also.
fridge also you have put.
Yes.
Okay, then where else? See, actually,
Then
for
no.
that
Yes.
that is for electrical use. Okay, if you are thinking about electronics, even for our microcontroller, okay, microprocessor, we need these regulators because it requires a constant supply which shouldn't be altered. So we use regulators and then we give the supply to the microcontroller or microprocessor. Okay.
Okay, ma'am.
So wherever plus 12, plus 5 now, next semester onwards, you will be doing your mini projects and all that time. Wherever constant voltage is required, you have to think about your regulator. Okay?
Okay, ma'am. Okay, ma'am.
Yeah. Any other doubt?
No, ma'am.
Yeah. Anybody else, any other doubt, please text me. I was told that this present third years are very enthused. Okay, they keep posting the questions. Now, what is this? I didn't get a single question, nor the answer. If I ask people to come online also, it is very difficult for them to come. Yeah, one question is there. Doubt. If in case we use LM79 in plus 5 volt, what will happen, ma'am? It is not a regulator. Okay, it is not a regulator. It is not even an amplifier. Okay, because I told you what is there that using error amplifier and all. I had in the PPT, I had shown you what is the internal diagram of the regulator. Now, if in case of like what is that 78, if you use 79, the configuration itself is different, so it is not working like a this thing regulator. It is not pulling down, it is not comparing, nor it is like any ordinary amplifier. Okay, so it gives you random answers. That's it. Okay, so that is the mistake. LM79, it gives you minus 5 volt. LM79 with proper C and R values gives you, okay, minus 5. If you don't do all those, it gives you random value. That's it. Yeah, that was one doubt. Okay, another doubt. How long should I wait? Are you people generating the doubt, or what is it? You have gone to passive state. No. Okay, Ashwit is texting, no? Any other question, Ashwit? Or should I wind up? Just answer, should I wind up? Okay, there is no question. So, shall I wind up? Ashwit? Okay, yeah. Since I didn't get any other Karthik, he also said, yes, ma'am. Right then. Okay, thank you. Go through if you have not understood, I'll be posting this video in the canvas. Go through that once again. Okay, fine. Okay, bye. Take care. Yeah, everybody has come now. Okay. He's texting all came now. Fine. We'll leave the meeting.